Hi, everybody, and welcome back to Dr. Barner's classroom. We're going to be today talking about early number sense and how students start to think about numbers and make sense of numbers in pre-K through second grade primarily. You might have students on either side of that who are more or less advanced, and that's just fine. But that's just kind of a general ballpark for what we're going to be talking about today. So, the first thing I wanted you to think about is with young children, we have to think about what they already come to school with. So, as we know, students don't come to school as a blank slate. It's not like they come to you and everything you teach them is just going to be absorbed, right, and regurgitated. They come to school with a ton of informal knowledge from their lived experiences, from their day-to-day lives, from the things they're involved in outside of school. And so it's important for us to think about what they already know and try to connect to that. So students might be familiar with sports, for example. That's a good way to get them thinking about numbers. Maybe they cook with a parent, or maybe they have experience at the grocery store with money. So there's all these informal ways that you can think about incorporating numbers into your lessons that are accessible to students because of their outside experiences. So these are some questions to kind of get you thinking about what students come to school with. All right, so here's a hypothetical scenario, and I'm going to ask you to do a little activity here with me. If young children are given the following problems, my little screen over here, on the next slide, how successfully could they solve each of these problems? So I'm going to give you a list of problems, and I want you to think about these things in particular. So um, the problems can be read aloud, so the students don't need to be able to read. We're really trying to focus on math here, so keep that in mind. So reading isn't really a factor. They do have materials available, like counters and cubes or whatever they might need, and they're not told how to solve the problem. So when I put up this next slide, what I'd like you to do is pause it and think about how you might order these. Okay, so we're thinking about sorting these problems by difficulty. So I want you to pause here and just read the problems and think about how you might order these from kind of easiest to hardest for a kinder student. Okay, so now we've moved on and we've got Moira here. Um, but either you paused it or you didn't. I can't really control that, but hopefully if you did, what did you notice about the ranking? So a lot of times when we're coming into lessons and thinking about problems, we think about things like wording or difficulty of words. We think about keywords, we think about structure, that kind of thing. But I want to point out a couple of important features of problems that really do impact their difficulty, especially with young learners. So we're going to talk about something called direct modeling. So we have Tyra and RuPaul here, who are some of my favorite models. But thinking about direct modeling is just what it sounds like. So do students have an opportunity to tangibly hold something and model the problem, the action of the problem? And so some of what's embedded in that is, does the problem have a clear action? Does the problem lend itself to a student being able to act it out with materials or with tally marks or anything like that? Okay, so it's a powerful strategy that children use naturally. And they don't have to be taught a particular strategy here. So this is the cool thing about direct modeling and cognitively guided instruction. So we're thinking about direct modeling, students use it naturally, meaning that if you give them a problem, they're going to naturally try to kind of like lay out something or draw it. You don't have to teach them, here's how you lay out the tiles, right? You provide the tiles, present the problem, and then allow them to do it in a way that makes sense to them. So if you teach them a particular way to solve a problem, even if you're letting them use manipulatives, that still takes away the problem solving piece of it. The whole thing is with problem solving, you have to leave it open-ended. So providing the materials, providing the task, but then letting them grapple and thinking about questioning. The other portion of CGI, or cognitively guided instruction, is the how easily can it be modeled. That determines the difficulty, and then where is the location of the unknown value. So you'll notice in those problems, some of them had, here, let me go back. Some of them had a start value, and then we took some away, and then whatever's left is what's unknown. But then in number 2 here, we have the start value, but we don't know how many more she needs to get the total. So you can see that start value and the final value are there, but we're missing the middle value. And that can be solved in a bunch of different ways, but it does increase the difficulty of the problem for a young learner who might be more used to something like number one, where it's, you're just trying to find that result. Just a quick example. Okay, so again, we're talking about following the action and the story of a problem. And so when you're thinking about how to give students problems that are slightly more difficult if you're scaffolding up, or slightly easier if you're scaffolding down, you can think about making it more action-oriented or less action-oriented, depending on which direction you're going. And then representing all quantities in the story. So they can use cubes, fingers, drawings, tally marks, etc. to model. So these are all things that are important in thinking about the task that you're giving a child. And one way to really think about this is bundles of 10. So when we're thinking about early numbers and what we want students to develop in terms of their habits of mind and their number sense, what we want to do is tie things to our base 10 system. So we want tools that can more easily allow them to visualize groups of 5, groups of 10, and eventually groups even larger than that. This lends itself to the foundations for operations and also subitizing, which is just knowing the quantity of something without having to count one by one, but like being able to look at a group and like make sense of it without counting one by one. We'll talk about that more in class. Multiplication, of course, and division, because we're thinking about organizing around groups of something, and groups of something, when we count them up, we multiply, and when we break them down, we divide. So these are all important foundational pieces that we can start really early when we're thinking about early number sense. So when we're thinking about direct modeling and bundling by tens, we can use something called a 10 frame. And that's what you see here. So we've got 5 on top, 5 on bottom, and then we fill it with an object. Here I have a rock cat. So looking at this quickly, how many rock cats do you see? So for you as an adult learner, you probably recognize I told you this is 5, so you can easily look and like take one away and say there's 4. Or you might have compared it to 10. But for a young learner, what they're going to do is count 1, 2, 3, 4. Okay, so they're not going to use those strategies yet, but the goal is to get them there so that they can understand those groupings and how things fit together, number families, all that good stuff, by exposing them to things like this. So there's lots of different ways to do that. But using the 10 frame, again, anchors, instead of just throwing out 4 rock cats, if we put it on a 10 frame, we're really focusing on those groupings. Okay, so here's another one. If there are 4 rock cats on stage and 2 more join them, how many rock cats are there on stage? So I had my 4 prior, and then I added 2 more. And so now I can see, so again, for those of us that maybe are more advanced adult learners, right, we're real familiar with numbers, we might say, okay, 5 and 1 is 6. But for a really young learner, they're going to want to go back. And this kind of tells you something about how they're understanding math and where they are in their progression. If they go back and count one by one, 1, 2, 3, 4, 5, 6, they're not using those groupings yet, but we're going to continue to expose them. So eventually they can say, oh, it's much faster to just say 5 and 1 is 6. And also this gets at that idea of the relationship between like 6 and 4, for example. So there's lots of different ways that we can use this to lay that foundational grouping. All right, so notice that the child would represent both the action and the quantity. So that's something that I want to just point out one more time. Okay, and then here's my dog Bella. She's adorable and a little crazy. Definitely a mutt, and definitely we're not sure what happened to her before she got to us, but we love her now. But this is her in one of her sweet moments. So if I have 6 Bellas at the park and 3 leave to go home, how many Bellas are left at the park? So I have a clear action in my problem. So if I were a young learner, what I would do is lay out 6 Bellas on my base, on my 10 frame. And then what I might do is take away 3, because 3 leave to go home. So I might cross them out, I might take them away, whatever. But you can see that I took them away in kind of an irregular pattern. And I just wanted to use that as an example that this is fine. This is good. This shows flexible thinking. I can still see that there are 3 Bellas left. So I'm going to get my answer correct, and I'm understanding the relationship. And this is a really good way to show students that you can represent on a 10 frame in different ways. It doesn't have to be these three, right? It can be any three, and we'll still have our Bellas left that are representing how many are left at the park. So just wanted to point that out. You want to encourage that flexible thinking, and then eventually students might start grouping them on these first three just because it's more efficient. But that's really, this demonstrates that I understand the concept. And again, I can I can think about now like the relationship between 3 and 5 and how 3 and 2 make 5, or how 3 and 7 make 10. So there's lots of different combinations here that I can play with. So base 10 frames are pretty handy. If you're ever working with kinder through second students, I would definitely recommend that you have base 10 frames handy and on you, and that you're able to use them and allow students to use them. You're going to have some students who might struggle at first to work with these because they haven't seen them before, and they might not have as much fluency coming into school as other students. They come in at all different levels. And you might have students who are way past that, and that's fine. They don't have to use the base 10 frame, but if they can have it handy as a tool, sometimes it can be very helpful, especially when you're working on numbers 0 through 10, like in kindergarten. All right, so again, these help children to organize their thinking. They help demonstrate what they're thinking for you as a teacher, and it supports all of these different foundations in terms of operations that you see here. So now we're going to have our cute little dog with a giant bow tie. So just to celebrate that our teacher taught us how to use a 10 frame to strengthen my knowledge of base 10. So just keeping in mind that even when we're working with young kids in early numbers, that we're working towards setting that foundation for place value, addition, subtraction, even fractions, because when we're thinking about base 10, it is a proportion thing, right? Like if you're thinking of fractions like or decimals, or like decimals are base 10 still, it's just an extension of the base 10 system. So all of these things can be tied in as early as possible, and you want students to be able to think flexibly about that. All right, so what do I do next? So we're going to complete the readings, not the quote log. We're not doing that. We're going to continue to review the lesson plan template, check the syllabus, come to class, email me if you need help, and know that you're still brilliant and you've got this. So if you have any questions, please feel free to reach out to me anytime, and I will be available to you, and I will look forward to seeing you in class. Bye.